In this video, you'll learn how to use the law of cosines to solve oblique triangles and find the area of an oblique triangle using Heron's formula. Okay, to begin, let's go over the formulas of the law of cosines in standard form and an alternative form. Okay, to start, we have a squared equals b squared plus c squared minus 2bc cosine of angle A. Then similarly, we have b squared equals a squared plus c squared minus 2ac cosine of angle B. Then lastly, we have c squared equals a squared plus b squared minus 2ab cosine of angle C. So we can clearly see the pattern here. To memorize this formula, it's pretty simple. All you got to memorize is whatever term you're squaring at the beginning will be the angle you're using for the cosine. And then here, if you're adding b and c, well, you multiply b and c here. So a and c, you're adding a and c, so you multiply a and c. So the alternative form, this can be rewritten as b squared plus c squared minus a squared all over 2bc. I'll go ahead and rewrite the rest. As you can see, these also follow the same pattern. Whatever cosine angle you're looking for will subtract the side length squared of that angle. So here, b, little b, big C, little c. And this is a much easier way to write this if you're just looking for the angle, and here if you're looking for the side. So either of these work, they're the same. These are all actually the same. They're just taking account different sides and angles. Okay, so let's begin with our first example here. Okay, so for our first example, we have find the three angles of the triangle whose sides length A equals 6 meters, B equals 8, and C equals 12. Round to the nearest tenth. Okay, so I like to begin by drawing a triangle, if I can. Okay, now to label the triangle, and the convention is using A, B, and C. So we're told that little a is 6, and then little c is 12, and then 8. So here we cannot use law of sines because law of sines requires at least one angle. And actually that angle must at least have a side in front of it. We should know the side of it. So in this case, law of cosines is literally all you can use. So to begin, let's pick a side we want to solve for. Let's begin with A. So cosine angle A is equal to, we're going to use one of our alternative formulas. And it's just another way to rewrite this. So we could be using the other one, it would work perfectly fine. Okay, so this is basically now plugging and chugging onto your calculator. Okay, so this is what we get when we put this in our calculator. And now we take the cosine inverse, because remember we want the angle of this number. And we get that this is roughly 26.4 degrees. This means that this angle right here is 26.4. And now what you can see, we know we're going to try to look for angle B. And we can just rewrite this as cosine inverse, because this is what we're going to type into our calculator. 6 squared plus 12 squared minus 8 squared. And remember, if you're typing this into your calculator, you do want to put the parentheses so you get the proper answer. Okay, so your calculator should give you cosine is equal to 36.3 in this angle B. And now, remember, all three angles must add up to 180. Well, with this knowledge, we know that angle C must equal 180 minus these two angles, which roughly will equate to 117.3. And we have solved our triangle. Another thing to note is that there is no ambiguous case types of problems with the law of cosines, so this is a much easier concept to keep in mind for solving with triangles. There is no ambiguous case, it's just straight plugging and chugging and memorizing this formula. But once you use this formula often, it'll be easy to memorize. Okay, let's go for another example. So given angle A, 80 degrees, B, 16 inches, and C, 12 inches, solve the triangle. Again, to recap, solving the triangle means finding all angles and all side lengths. So let's begin by drawing a triangle and labeling it. Okay, as you can see, we cannot use the law of sines here because this angle does not have this corresponding side. So yeah, this is why you would have to use law of cosines. Okay, so let's solve for side A. So using law of cosines, we know that A squared equals B squared. Okay, plugging this in, we'll have and we would take the whole square root of this. We would get roughly 18.3. So that is A. And again, now you can just go ahead and do law of sines, which is typically much faster than doing law of cosines because it doesn't require you typing in too much into your calculator. But for the sake of practice, let's do angle B with cosines, law of cosines. So angle B will be equal to cosine inverse of this should be equal to 59.5 degrees. And again, if you're doing this into your calculator all in one step, be sure to put parentheses on each term in order to get the correct answer. Okay, so again, with our knowledge of 180 degrees, subtracting this, we'll have that the angle C is 40.5 degrees. And we have solved our triangle. Okay, so our next topic of discussion will be Heron's formula for the area of triangle. So this formula will allow you to find the area of an oblique triangle. Typically, we would use 1/2 base times height, but since this is not a right triangle, we cannot use that formula. So given any triangle with side lengths A, B, C, the area of the triangle is A equals S minus A, S minus B times S minus C, where S here is the semi-perimeter, 1/2 its perimeter, or S, this is how you find the semi-perimeter. You add up all the sides and divide by 2. So basically, to memorize this, all you have to do is add up all the sides. So once you have all the sides, then you divide it by 2, and that's your S, your semi-perimeter. And then you simply take the square root of S times S minus each side length. That's it. You should have the area. Okay, so let's apply this to one example. Find the area of a triangle with side lengths A 31, B is 52, and C is 28. Round to the nearest hundred. So you see we have no angle here, and we don't need an angle. However, if we were missing a side, well, we would need an angle. So this is straight application. So S, Again, we need to find the semi-perimeter first. And this doesn't matter what order you write these, since we're not subtracting or anything. So we'll get that the semi-perimeter is 55.5 yards. And now we apply this to our formula. A equals 55.5 minus each side length. And again, since this is being multiplied, it doesn't matter what order you write these in. And you should get 361.77 squared yards because, well, it is the area after all. So that should be your answer. I hope you found this video helpful. If you do, please check out the other trigonometry math videos I have on the channel. And feel free to let me know what other videos you'll like me to make in the future. Thank you.